In this video, we're going to look at another example of trigonometric substitution. In this case, we will have the sign substitution. So here we have integral of root of 4 minus x squared dx. The pattern that we have is root of a squared minus x squared. So the transformation that we will apply is x is equal to a sine theta. Take the derivative of both sides, we get dx is equal to a cos theta d theta. So the integrand that we have is root of 4 minus x squared. That means x is equal to, well, 4 is just 2 squared, so x is equal to 2 sine theta. Dx is equal to 2 cos theta d theta. All right, so let's simplify the integrand. Let's get it in terms of the angle theta. 4 minus x squared, that's equal to root of 4 minus x squared, that's 2 sine theta, all squared. That gives us root of 4 minus 4 sine squared theta. Factor the 4 out and remove it outside the radical, and we're going to get 2 root of 1 minus sine squared theta. Now, this is where the trig identity comes in. 1 minus sine squared is just cosine squared theta, because cos squared theta plus sine squared theta is equal to 1. So we get 2 root of cos squared theta. That gives us 2 times absolute value of cos theta. But we can get rid of the absolute value and write this as 2 times cosine theta. The reason we can do that is because cos theta is a positive quantity when theta is between pi over 2 and negative pi over 2. That means we don't need to write the absolute value. So what we have shown through a trig substitution is root of 4 minus x squared dx is equal to integral 2 cos theta times 2 cos theta d theta. This part, 2 cos theta, is just going to be root of 4 minus x squared. This part, 2 cos theta d theta, that part is just dx. So what we have is integral root of 4 minus x squared dx is equal to integral 4 times cosine squared theta d theta. So let's bring out the 4, factor it out, we get 4 times integral cosine squared theta d theta. And this is where we will apply the half angle identity. That gives us 4 times integral 1/2 times 1 plus cos 2 theta d theta. 4 times 1/2 is 2, integral 1 plus cos 2 theta d theta. Now if we integrate this, we get 2 times, what is integral of 1? Well, that's just theta. What is the integral of cosine 2 theta? That gives us sine 2 theta divided by 2. That's because of the U substitution. If you had integral of cos theta, it would just be sine theta. But we have integral of cosine 2 theta. That means we have to apply U substitution. Let U equals 2 theta. The U is 2d theta. So that's why we get sine 2 theta divided by 2 by reversing the chain rule. So what we get is 2 theta distributing the 2 plus sine 2 theta plus c. So, but we have to remember there's another trig identity we can use, sine 2 theta. The double angle identity is 2 sine theta cos theta. So the result is 2 theta plus sine 2 theta. This part, applying the double angle identity, we get 2 sine theta cos theta plus c. What we have shown is the integral root of 4 minus x squared dx is equal to 2 theta plus 2 sine theta cos theta plus c. But we can't just stop there, because the answer has to be in terms of x. The answer that we have is in terms of theta. We have 2 theta plus 2 sine theta cos theta. So somehow we have to change all of this back to x so that we can get our answer. So let's do that. What we have is integral root of 4 minus x squared dx is 2 theta plus 2 sine theta cos theta plus c. The trig transformation we applied was x is equal to 2 sine theta. Divide both sides by 2 and we get sine theta is equal to x over 2. That means theta is equal to arc sine minus 1 of x over 2. So let's draw the reference triangle. So what we have, here's our triangle. We draw a 90-degree triangle. And here's our theta. Sine theta is opposite over hypotenuse. So the opposite is x, hypotenuse is 2, and we calculate the missing side by using Pythagoras. So we get root of 4 minus x squared as the missing side. So now, if you look at this triangle, we're going to need theta, right? And theta is just arc sine of x over 2. We're going to need sine theta. Well, that's just x over 2. What about cos theta? Well, cos theta from the reference triangle is adjacent over hypotenuse. That would be root of 4 minus x squared divided by 2. So what we have shown is the integral root of 4 minus x squared dx is equal to 2 theta plus 2 sine theta cos theta plus c. Now we can bring everything back to x. So this reference triangle is very important because it allows you to change your answer in terms of x so that we can solve the integral. So what we have is 2 times theta, and theta is arc sine of x over 2, sine minus 1 of x over 2, plus 2 times, what is sine theta? Well, sine theta, that's just the trig substitution that we applied. That's x over 2. What is cosine theta? Cosine theta is root of 4 minus x squared divided by 2. The 2's cancel. And let's simplify this and get our answer. So we get 2 sine minus 1 arc sine of x over 2 plus x root of 4 minus x squared divided by 2 plus c. That is the antiderivative. That is the answer to this integral root of 4 minus x squared dx. All right, thanks.